This is an intro video describing the test setup and test process for the Rotor Crowbar. It's a PCA 1DCE 1427 for TMEIC. First part of the test, we're going to look at the setup. We're going to begin with the controls. The control power is actually coming from this variac. It's plugged into the 120. With this variac, we can actually control from 0 to 250 volts. It goes from here. We have a clamp meter to monitor the current, and we're going to be using this meter to measure the voltage of the control power. Control power is actually hooked up on the assembly, the TB1 pins 1 and 2. On the controls, we also have a toggle switch from pins 3. There's a toggle switch which connects to pin 5. We have a jumper from pin 4 to pin 7. The 24 volts from the DC power supply, which will help us do a manual crowbar. The positive is hooked up to pins 5. Alright. From pin 5, there's also a 4.7K resistor that goes from pin 5 to pin 6. The return for the 24 volt DC goes to pin 7, and pin 8 is hooked to the assembly chassis ground. The output and load settings, from the positive side here, the wire that goes through here into one side of the inductor. From the other end of the inductor, it goes into our lamp load. We have 6 lamps all connected in series. From the end of that lamp load, it goes into the negative of our assembly. Monitoring devices. As I stated earlier, for the control voltage, we're using a clamp meter and also this meter here. For the input voltage is actually coming from this variac. It's applied through 120 volts from the variac, and we're able to control the primary of this transformer. This transformer is set up for 120 to step up 120 to about 6,000 volts. For this test, we're only going to go to about 1250. These pins right here are the primaries of this transformer, which is fed in from the variac here. The secondary, the high voltage, is actually on this side of the transformer, which is labeled high voltage. And the return of that is we're actually going to use a tap on pin 3. High voltage is fed from the secondary of this transformer, and it goes into 2 of our lines. This assembly is a 3-phase system. We're going to be testing this assembly with a single phase by just rectifying a single phase signal. And then what we'll do to check the other side is we'll switch these L1, L2 to L1, L2. Also, for the monitoring devices for the input voltage, we're going to be monitoring the input voltage, which is connected from this plug and through this high voltage probe. The return of the high voltage probe, we're actually hooking up to the return of the secondary of the transformer, and we're using the meter labeled AC input. We're also monitoring the input voltage through on the oscilloscope. We have a resistor attenuator here, which is connected to our differential probe. We're using a Fluke DP120, which is this one right here, and that is hooked up to channel 4 of our oscilloscope. We're also monitoring the input current through this CT. It's a Pearson CT. From the CT, you can see we have a BNC cable that feeds into our oscilloscope, which is hooked up on channel 3. Monitoring devices for the output, we also have a high voltage probe, which is across the SCR. Positive is hooked up to the anode side, negative is hooked up to the cathode of the SCR. And from the high voltage probe, we're using that meter labeled DC output. We're also monitoring the output voltage on the oscilloscope using a differential probe. That probe is actually hooked up. We're also using an attenuator resistor network here, which is hooked up to positives here. Negative that is hooked up to the other ring here. Okay. That concludes the setup. We're going to go ahead and start the test of the Rotor crowbar. This is going to be a two-part test. We're going to be testing both the manual crowbar and the autonomous crowbar. To begin the test, we're going to turn on our control power, and we're going to adjust the variac so we have 240 volts control power. There we have roughly 240 volts. Okay, as we power on the board, we can see on the assembly itself. Okay, I went ahead and turned on the 24 volt DC. And if you look on the assembly, we can see that the power LED on the trigger board is on and the crowbar is off once I turned on the 24 volts. The bottom board is our snubber board. If you look to the bottom there, that LED that you see on is the crowbar ready. We also have two LEDs towards the middle. On the right hand side is our high voltage LED, and the LED right in the middle is actually the crowbar LED. Okay, so now since we have our control voltage on and our 24 volt DC to do the manual, we'll go ahead and turn on the line. Okay, we're going to look at our meter, and what I'm going to do is I'm going to slowly bring this up to about 800 volts AC. I did a little bit over, so we have about 840 volts AC input. The rectified voltage is 830. Alright, so we're going to go do a manual crowbar by toggling the switch over here. As I toggle the switch, you'll see the LED on the firing board turn on for a manual crowbar, and it turns on. We'll look at our oscilloscope. You can see as I triggered, we set it up so when we trigger the crowbar, see the sine waves there. Also on the snubber board, you can see that the LED went from high voltage to the crowbar. I believe the video there, as I turn it back on, it goes from crowbar to high voltage. Okay, so that's the manual trip for the crowbar. Now we're going to do the autonomous trip for the crowbar. So we're going to look at the oscilloscope, and since on the board we have 6 side acts, which each side act's about 200 volts. We also have 2 Zehners that are 25 volts, so our breakdown voltage should be about 1200 or 1250. So we're going to go ahead and increase the input voltage, and we'll be monitoring the DC output. When we reach about 1250, we should see the crowbar for autonomous. Okay, so a crowbar, you can see on the oscilloscope the trigger. Now we're going to look at the assembly itself. You hear the clicking noise, and if you look on the bottom, you can see that high voltage LED flickering, and that's normal for this part of the test. So I'm going to go ahead and turn down my input voltage back down to 0 and shut that down. I'm going to shut down my control voltage and 24 volt DC, and that will conclude our test for the Rotor crowbar.